Okay, Advent of Code, day 6. And 7. Probably going to do them both at once. You're also going to notice that I'm switching to NeoVim instead of using VS Code, because I finally got that set up how I like it again. I'm going to read through this, and then we'll resume. Okay, I think I follow what needs to be done here, so let's give this a try. So to start with, we can write our test, and we can say assert task, pass task 1, and they gave us a nice input here. There we go. And we are going to assert that this is equal to 5934. Okay, let's start by writing. Our pass is going to be very easy. We need to use nom complete. Nom character complete U32. We need to use separated list 1, and we need to use combinator map. Our output is going to be. Now I'm thinking, let's start by structuring it as just so because we don't know if in part 2 order is going to matter, let's start by structuring it as tree map, but eventually I want to adjust this to be as a vec, but eventually I think this should become a B-tree map, where we map the number of days remaining to the number of fish that have that many days remaining. It's annoying that I don't know what part 2 is, but let's just say fish timings is a vector of U32. And then we will say pass, and we also need to just bring in parser for new style parsing. Separated list 1. We also need car from in there. So we have car of comma U32. And then we're going to just map that as fish timings. Past input fish timings. Parser.pass on input. Okay. And now in task 1, let's just debug our fish timings, just so that we can check that they are all as we expect them to be. We're going to do run, runnable, Rust runnables, and test. It says 3, 4, 3, 1, 2, which is what we got. Correct. Okay, so we're passing okay. Now let's say our fish timings be tree map of U32 to U32 to U32 is equal to B-tree map, or I will say is equal to input dot fish timings dot fold. So we have a timing. Initially we need to pass into fold a tree map new, and we have mute timing. Here we can say time, and we can do timings dot entry timing, or insert 0 plus equals 1 timings. Good for okay, so that gives us our fish timings. Now all we want to do is just say for in 0 to 80, and we want to just update our fish timings, and the way we're going to update it is by saying okay, so every timing needs to write to the next timing that needs to go to, but we don't want to have the issue where we write to kind of overwrites values that exist, which is an issue. So we'll say next timings is fish timings iter dot map timing count. We want to do timing -1, and we want to collect that. So we'll just say, we say fish timings is equal to this. Formatting going on in here. Okay. Yep, so that gives us our fish timings, but we don't want to just subtract one. What we want to do is we want to say if let sum next is equal to timings dot checked timing dot checked sub 1. Next count else we actually want to flat map because we can introduce new elements, so this will be a vec of one element, and then in here we will have a vec of 2 elements. Our first one will be the fish resetting to a 6. And the second one wait, no. Yeah, okay, and then we will also be introducing 8 of count, because they're going to duplicate. Yes. Introduce 6 count and 8 count. Okay. Anything else with incompatible types? No, they do not. I need to put a asterisk here to dereference these. Okay, perfect. So that updates our fish timings 80 times. Fish timings dot values dot sum. That feels like it probably works to me. And gives us a size. Let's run our test. Okay, definitely not. Left is 10. Okay, something clearly going wrong somewhere then. Let's just do debug fish timings at the top of yeah, let's do it at the top of every loop, and that should show us what's going wrong. So we've got 1 on 1, so they all decrement by 1, and then decrement produce 1 on 6 and 1 on 8. Okay, so the problem is 6 count is overwriting, whereas 6 count needs to be adding. So rather than flat mapping and collecting into an iterator, we need to do kind of like a post-process step, because so the issue is that 6 count here, whatever the latest 6 count is, will overwrite things even if there's stuff that's been subtracted down from 8 and has hit 6. So we're kind of artificially not allowing it to properly accumulate. The way around that is so 6 is the only merge point, and it only happens there. So let's say let me see, merging in 6. We could just use a vector and not use a B-tree map, but then I feel like we're going to run into memory issues if they give us a big enough list, which I assume they have. Yeah, let's the way to do this is to say let next timings be tree map new, and then let's say wait, fine, okay, yeah. Next timings is a new B-tree map, and then for timing in fish timings, for timing count in fish timings, next timings dot entry timing dot or insert 0 plus equals count, except it is if let sum next is timing dot check to sub 1. Then we do this on next, else we do this on 6, and we do this on 8. And then down here, all we need to do is say fish timings is next timings, which means we could do this with a fold. So let's do that. So instead here we'll say it's a fold. We're going to build the next iteration of the map. Next timings, timing count. Let fish, not let, just fish timings is equal to this. Next timings needs to be returned at the bottom. And then all of these need an asterisk at the head of them. Nice, okay. So I think that should be working nicely. So let's run test again. It passed. Okay, nice. In that case, cargo run, util release run, year is 21 and day is 6. It's not called P, it is bin. And that is going to run it, and we get back this number here. Right answer for part 2. Suppose the lungfish live forever and have unlimited space. How many would there be after 256 days? Okay, cool. So it is a question of, are you going to run out of memory in whatever allocation you're using? / is it going to take too long? I thought it might be, so I was correct to sort of defensively code against that. In that case, let us do our initial fish timings process here. Where we grab this. And it is yep, and then this here is a B tree map. Now, fish timings initially, we'll just call this next timings is input.fish timing. Oh, we'll just overwrite fish timings. Let me fish timings dot clone, and the reason we do that is because we are gonna mutate it. Tree map from U32 to U32. Nice. Some U size, some U32. Okay. Sure, let's make it a U size. Whatever. U size. There we go. Now it type checks correctly. Okay, and so now our task 2 is exactly the same as task 1. But we need to go to 256 days. And for our input that we got there, goes up to this ridiculous number. At my task 2, I am suppressing the input because from before. So let's test that. And we need to say that the return of this is a U size, and we'll test that. And it's inferring it as an I32, for which it is too big for. Sure. And it passed. And we get this gigantic number. And that's the right answer. Okay. Sure. So let's save that and scaffold day 7. 7.rs 2021 day 7. Okay. And let's have a look at day 7 on here, and I'll get back to you once I've read this. Okay, so I've had a read, and I've also had a thought, and I want to just try something. So we're going to just do this in a playground instance real quick. So what I want to look at is what this looks like sorted. Because something tells me who is the middle value. I wonder if it's just the median of the sorted list is the correct value. I don't know why, but I felt like that was the case. I guess we can just try that, and then if that doesn't work, we can try something else. So let's do that anyway. So our test input is still just a comma set or repeated list, so we can just assert task pass task 1. This in a string, and we're meant to give an output of 71, I think it was. $37, sure. Okay, cool. And then this here is crab places is a vector of, we'll just again use U32. And you know what? Let's just it's the exact same input format, so I'm just gonna steal our parser from last time and swap fish timings for crab places. Refactoring set up yet, and there's no convenient Rust refactor. No, okay. Crab places, and then this one doesn't need to be a B tree map, it is just a vector. Okay, and then that should be something's gone odd here. Open the file and let Rust Analyzer get its teeth back into it. Until it does, I guess I can cargo test bin Y2021D07. A spelling mistake. Apparently this exists now. Aha, spelling mistake is here. That looks like the correct input. Okie dokie. So, with the correct input sorted out now, and my lint's on, positions is equal to input.crabplaces.clone. Let positions.sort unstable, because I don't care if it's stable or not. Positions and positions.len divided by 2. Median is equal no data. And then we want the sum of the distances from the median, so it is simply positions.map. Let's use an I32. For easier parsing. Turn an I32 here. N median minus N dot abs dot sum. I don't know why my lints aren't working right now. A bit concerning. Right, yeah. It's just called get, not nth, when it's not an iterator. If I say buffer diagnostics, interesting. Okay, well, I'll need to look into that. Now we'll do this the old-fashioned way, and positions obviously here needs to be positions into iter. And in case median is borrowing, it is, we will just dereference it. Because I32s are copy safe. Now that passed, but is the median approach correct? Does running it work? Obviously we get like a number, but is that the correct number? It is! Okay, so the trick of using the median is probably correct then. That or I'm extremely lucky. Okay, part 2. I'll read this and get back to you. Okay, so this next one is interesting. It is computing triangle numbers. Because 1, 3... Oh no, wait. Yeah. Yeah, it's computing triangle numbers. The n plus 1 divided by 2. Sure. So for task 2, we take all of this. And then once we have the median, we can say that that is going to be called our new value of n. Let n equal that. And then we want to return n times by n plus 1, all divided by 2. Oh, and this needs to be here. This needs to be an I32. What do they want for the test? They want it to say 206. Alright, I need to specify its task too. Okay, it liked that. Let's run that on ours then. So that is... Run it on day 7. And we get back this big number here. And that is too high. Too high. Yet it passed for the original input. Wait, how does it it passes my test? Passes test. It gives off the expected answer of 206. But when I try and run it, we get a number that's too high. I'm just gonna swap you for an i64. This should not at all be the fix for it. But I would kick myself if this did like, if this was the solution. No, you see, these numbers aren't anywhere near big enough. Oh, it's no longer the median. Okay, so the thing is, I've said that 2 costs 206, but that's no longer the cheapest. Because it's no longer the median, because now relative position matters more. Okay. Let's, so we can't use the median to figure out our target. Instead, how would we figure out the target? We have a different scaling factor. So we need to... Okay, so triangle numbers are nice in that they're subtractive, right? Like if we subtract so like 5 is 15 and 6, no, they're not. Okay. Yeah, of course not. I don't want to have to check every single position. I mean, it's cheap to do, and we can. But given that the median was correct for the first one, I kind of wish there was an equivalently smart solution. But I don't think there is. Really annoying. So let's just say 4 positions in positions dot into iter dot permutations. Say you know, we'll just say positions input dot crab places dot iter dot permutations. Input dot crab places dot len. Dot map positions min Oh, and no longer median now, it's just... we're going to try a new... We don't need to try every permutation. Hold on, I'm being silly. All we need to do is do let max is equal to input.crabplaces.max. I guess we'll do into iter.max. Yeah, okay, that gives us an option. Okay, and so that gives us an I64, and so then we say 0 to max. Iter target. Change this word here to target. Min. Into iter takes 0 arguments. Oh, okay, I just need to say into iter.map. Change that to iter, and this should work. Remove the word mute, just dot crab places dot iter. Gives us this number, which is the correct number. Okay, I don't like that I'm just checking every possible value, but I can't think of a clever solution like using the median for the first one, so that's what I'm going with. Thank you for watching.